Good morning, good afternoon, and good evening, everyone. So today we're going to be talking about low rank complexity. So here now we're going to dive into the complexities of what it actually means to be, well, low rank, right? So let's start with a scenario here. So let's say I have my A. Let me just move my stuff. I have a matrix. I have two matrices actually. So I have A and B, and they have m by n dimensions. Uh, and let's say their ranks are the same. Well, obviously, because they have the same dimensions. And that's going to be equal to some k that I don't know. So then my A is going to be, we're going to use that UV that we did previously. So U sub 1, V sub 1, transpose my V. And then for my B matrix, I'm going to do U sub 2, V sub 2. So I'm doing the same thing as the previous one I did here. I'm going to do a UV uh, decomposition there. So I'm going to do that. Um, okay. Then we're going to say that my U1 and my U2, let me just put that nicely. So my U1 and my U2 are going to be M by K, while my uh, V1 as well as V2, well, they're going to be N by K, right? Okay, so we're gonna do a MATVEC complexity here. And what is this? Well, this is let's say my vector x, which has n by 1. Um, Now I do my Ax, and here I just say U1 V1 transpose times x, right? Okay, let me put this a bit down. I need a breather. There we go. So yeah, we just switched A for my decomposition, right? Here we're doing a we're gonna analyze a matrix vector complexity if we were to use um, a decomposition. Well, this is going to be what complexity? It's k 2n minus 1. Well, now let me try this. So here we're doing an LU decomposition. So I have my U sub 1y. This is going to be equal to b, right? And then this is m by 2k minus 1. And so those are the two things, and the total complexity then of these two would just be to add these together. M by 2k minus 1. Okay. And so here we can definitely see this is faster compared to just doing it AX, right? If we were to do it AX, we would get, if I'm not mistaken, um, pretty sure we get some complexity. We get, let me double check. Yeah, this was in a very old video. Something about counting complexities. Matrix multiplication. Where's the math back? It's a dot product. Uh, Let me double check. Oh, math back. There we go. So this one is, oh, it's O n squared. Let me actually see. Is this better? Let me see. 2nk minus k, right? I'm just substituting. 2km minus m. Uh, 2nk minus k plus. I have like three things here. Uh, is this better? Well, it's not squared. Using an LU decomposition makes it better, I would say. But again, I'm still not super sure. It should be better though. This looks like linear complexity to me. Yeah. If I were to put this together, well, this is ONK. This is probably OMK, maybe. I like do things here. Uh, is it better? ON squared. I get the feeling it is better. Because why else would we? Yeah, it's ON squared. Let me see. Let's uh let's look at that in a bit. Okay. Hmm. So that's the math-vec complexity if we do something low rank. Okay. Now what if we do a matrix multiplication? What if we do that? So what if we do low rank and we do matrix? Well, if we did this, we want to see if we can keep that low rank structure, right? So how do we keep that low rank structure? Say we're given two matrices. I'm gonna say my A matrix and my B matrix, right? I'm gonna transpose one of them, and I'm gonna say that's equal to uh, U1 V1 T transpose, and I'm gonna multiply that to U2 V2 T, and I transpose that thing as well, and this should give me uh, U1 V1 T, and then this should give me V2 V2T, right? How did that work? I have my U1 V1T done. My U2 transpose, then my oh, did I mess it up? Oh my bad. This is supposed to be my V, and then this is supposed to be my U. There we go. Just to make it, this one's a U. Yeah. If I were to transpose something that has been transposed, well, it will go back to the normal or the original thing, right? Because I'm just switching it around. And then from there, well, what can we say about it? Hmm. Well, we have to make assumptions here. Uh, let's think. Well, what if we assume that, okay, what if we know these two V's, right? And I'm gonna call that what? V sub 3. Let me do that. V sub 3 is gonna be an element, or it's gonna be what? How many dimensions? If my V sub, did I define it? I probably didn't. Okay. Well, that's probably gonna be some k by k, right? Like transpose. So I'm gonna say like what? If my V was, I don't know, m by k, and then my other V, if I transpose it, well, now it's k, or it's the other way around. Oh shoot, it's the other way around. V k by m, and then this one is m by k, and so we cancel these, so we get k by k, which is what we have. And then so we got that, and then what happens here? Well, the complexity would just be k squared to n minus 1, right? That's the complexity of that. But then what if we were to do something else? Let's look at the complexity, let's say when we expand this out a bit more. So how about we equate this to u1 v3, right? Now I plug in my v3. And then my u2 to the t, right? Now I completely took this out. I made it v3. And then from there, well, let me analyze this part. U sub 1 v sub 3. What is that? I don't know. We'll call it u tilde. Too many variables. U tilde is, well, n by k. If this is k by k, okay. And then from there, our complexity is just mk to k minus 1. Mk to k minus 1, right? And then from there, well, now I have this left. So u tilde u to t. I'm left with that, right? So I have like two complexities here. What else? What else? What else? Well, yeah, now I'm left with, I'm assuming this is, oh, this is a U. So my C now, in this case, is that last term that we, or the last solution that we got. And so I'm going to say that, okay, well, my C is now U tilde, U sub 2 transpose. And this is a low rank form with such complexity. So this is a low rank with, I'm going to say low rank form with this complexity. And that's going to be, well, the two complexities we got added together. So it's going to be k squared 2n minus 1. I add that to mk 2k minus 1, right? And from there, but yeah, so it really can't really again tell if it's better. I think it's worse, but I'm not sure. Not super sure. Yeah, because I can't find a way to simplify these. There's just too many variables. I'm just analyzing their complexity using in a low rank form. That's really all we're doing here. We're just analyzing their computational complexities after we've done their low ranks. Okay, we can also do additions, right? It's also one thing we can do. Let me do low rank additions. So we did matrix vector multiplication. We did matrix multiplication. We can also do it for additions. Honestly, we can do it for anything, if we're being honest here. I don't know. Let's just do A plus B, right? We have two matrices, right? Let's do that. U sub one, V sub one transpose. We're gonna add it to U sub two, V sub two transpose, right? And from there, we have, let's decompose this. U sub one, U sub two, right? And then, well, here I have V sub one, V sub two. This is transposed, so I'm gonna make it a. Okay, let's characterize these things. Well, this one, U sub one, U sub two is, uh, what is this? I'm gonna say it's M by 2K, right? This is M by 2K, as well as this. This is, again, N by 2K. Okay, and then from there, uh, well, that's the rank. So A plus B becomes a rank that's 2K matrix, right? And so it might be well approximated using a rank K approximation. So we could just approximate it. But in a lot of cases, it will not. So it depends on the context of the problem in which the matrices arise. So it really just depends on how we want to go about it, especially for adding. Yeah, so that's it for analyzing low rank complexities. I hope you guys learned something. Maybe if you guys know this is probably a review. But yeah, I hope you guys enjoyed, learned something, and I'll see you all in the next one.